We're going to make a simple calorimeter and see how much energy is in a peanut. I'm using dry roasted peanuts. They work good for this setup. Usually I'll use dissection pins, but I don't have any clean ones right now, so I'm just using a push pin. I'm going to use some aluminum foil to make a base so it's a little more stable. And it doesn't tip over when I put the peanut. That should do. I have an aluminum can. Aluminum cans work better than glass because glass is an insulator, and this will transfer the energy in the peanut efficiently to the water, which will be in this can. I have 100 milliliters of water, and that's going to go into my calorimeter. This can holds about 300 milliliters. So I'm filling it about a third way. I have this ring stand and triangle set up. It's not the most stable thing, but we'll see. I put a styrofoam cup. It'll act as an insulator. And actually, before I do that, I'm gonna get the mass of my peanut. I don't need to do this, but it'll help me get the energy in terms of per gram. So 0.69 grams is the mass of this peanut. Let me write that down. Now we need to get the initial temperature of our calorimeter, specifically the water in the calorimeter. Missed it. The initial temperature of the water is 24.8 with an estimated digit, 24.8 degrees Celsius. What did I just say? So that's on there pretty stable. And now see if we can balance this guy. Oh, by the way, I made this heat shield to better transfer the heat without loss of heat. But I'm not going to use that because it'll block our view. And I don't think it'll... It's the concept. There we go. All with one hand. Okay. It shouldn't take long to get started because these are dry. Wow. So you may be surprised how long this peanut is burning. There's a lot of energy in peanuts, or in nuts in general. Let's check in on our thermometer. Oh, there it is. So the level is over 40 now. And the flame's still going strong. Oh, now it's dying. Looks like the peanut is out. Look at that. I'm going to note the highest temperature as my final temperature. Right now it's at 44.8. And now it's dropping. So I'm going to record that 44.8 was the high temperature. That's going to be my final temperature of my calorimeter. Let's get the mass of our peanut. 0.08. Wow. So this is the initial mass. Let's do some calculations. Here's my data. Now you should have done at least 2 trials. So here's our peanut, and that represents the system. The only other thing that exists in the universe is the water in our calorimeter. That represents the surroundings. The chemical potential energy in the peanut was converted into thermal energy when we combusted it. That was then transferred as heat to the surroundings, which increased the temperature of the water. That's what we measured with our thermometer. We're not going to do calculations with the peanut. We're going to do calculations with the water. So we have the delta T of water. We have the volume of the water. So we can calculate the heat absorbed by the water. And once we get that, that's going to equal the heat produced by the peanut. So let's plug in these numbers. Because the density of water is about 1 gram per milliliter, 100 milliliters of water is about 100 grams. You can do the dimensional analysis. The specific heat of water, that's given to you 4.184 joules per gram degrees Celsius. And the change in temperature, that's delta T, is final minus initial, and that's 20 degrees Celsius. So about 8.4 kilojoules. About 8.4 kilojoules of heat was absorbed by the water. And that's going to equal the negative Q of the system. Therefore, the heat produced by the nut is negative 8.4 kilojoules. So you may be wondering, why do we measure the mass of the nut? Well, that was 2 parts. When teachers give students more information than they need, they oftentimes do worse. So that was just a distractor. But if you wanted to use it, you could get the energy content per gram of the nut. So let's do that. So the mass of the nut that burned is the difference between the before and after mass. So 0.61 grams of the peanut burned. Let's change this to a positive quantity because energy content isn't going to be negative. So about 14 kilojoules per gram. And just to clarify, this quantity describes the heat released by the nut. But because we know the nut didn't do any work, we can also say 8.4 kilojoules of chemical potential energy was released as heat.